You will notice this is not Jason Rhoades. This is Gina Berg. Jason was not able to make it in, so Gina is stepping in to do this presentation. We are going to be supportive and rally around her because this is an awesome opportunity. And we will do the best we can to get all answers questioned. I'll keep it like that. And have a great experience. So give it up for Gina. Actually, let's just go ahead right off the bat and tick off Ballroom C. Let's give it up for Gina.
Hi, everybody. I'm here to talk about data ingestion and normalization. First, we'll go over the agenda. We'll start off by discussing some problems you'll likely face as your company grows in size and maturity throughout the cloud. Next, we'll walk through Intuit's data pipeline and how we use that as the foundation to solve those problems. Then we'll look at how different data sets act as the key ingredient to different solution recipes. And then last, we'll go through a few examples of how 3 very different sounding problems can be solved by the same FinOps data approach. So hi, I'm Gina, obviously not Jason. As he mentioned, Jason tested positive on Friday, so I'm stepping in. My role at Intuit is a staff business analyst. I'm serving as the customer liaison between our cloud cost monitoring tools and all of the users of the tools. And so I'm definitely not as knowledgeable or articulate with this area, but I'm going to do my best. And Jason is available on the FinOps Slack channel if you want to ask him real time any questions. He said he's going to be on and he can answer those questions. So first I'm going to start off with just sharing my exposure to this area. I started Intuit, I have a finance background, and I started in the finance department. And one of my roles was to forecast for hosting costs of TurboTax. And so I was a heavy user of all of our cloud tools and waste monitoring tools. But I really had no idea the amount of work and processing of data that went behind producing the data that I was using in the tools. And then I joined the FinOps department. And we walked through the ETL process, which took like 5 hours, by the way, and it was high level. And I was blown away with the amount of effort and refinement with processing of data that went behind generating the data that I was using in the tools. Just a simple on paper sounding allocation has just huge lines of code, and it just amazed me. We actually just walked through the ETL process again last week because we had some new hires. And still amazes me to this day what goes on behind the scenes. All right, oh, that is the wrong way. So let's talk about some modern FinOps problems. As your company's footprint grows in the cloud, it's likely that you're gonna encounter challenges that are beyond the scope and complexity that can be handled by your cloud vendors or third-party offerings. And it's not necessarily that they can't handle them, it's just that the problem needs to be pervasive enough amongst their customer base to warrant the time and resource investment for them to consider implementing the project or solving the issue. And so we should actually be making these same ROI evaluations internally as well with our customer requests. So we should be following that strategy. And so as these situations arise, we have 2 options. We can either settle for the best that the industry can provide, or we can make internal investments in solutions that are tailored to your organization. And that's really where data engineering comes into play. Data engineering is the heart of durable quality solutions because without good data to employ, everything else is meaningless. You can't use a dashboard if it's providing inaccurate information. And so let's walk through Intuit's FinOps data pipeline. First, we extract the data from all of our relevant sources. Just to give you an idea of how much Intuit has grown in this space, is when we first started in 2016, we had the AWS Cur and then about 5 to 6 other sources. And now we have over 100. And our AWS CUR is about 3 billion rows of data per month. So once the data is extracted, it's staged in our warehouse, and we bring in all available information into the warehouse. And we use Amazon Redshift. Once it's staged, we can then clean the data. And we clean it by applying data types. We delete any columns or rows that are unnecessary, and we preserve the contents for history. Now with clean, workable data, we can apply the business rules. And this is where, if I was a celebrity on MTV Cribs, I'd jump on the bed and say, this is where the magic happens. Because this is where the magic happens of data engineering. But it's only possible with all the preceding homework done before this, and it has to be done complete and accurately. And so this is where we would also make our ROI evaluations with our internal customer bases. A lot of customers are going to want allocations of costs in their very specific way, but they're the only business unit or team that wants to view costs that way. So we have to decide if it's worth the investment, and if not, either proceed or do not proceed. All right, so with the rules run, we can prepare the data for various delivery methods. And that would be our BI dashboards, custom web apps, raw data feeds, APIs. Different customers consume data in different ways, and we like to accommodate for everyone. Oh, and I'll just say that there's a lot to data engineering and warehousing. There's entity relationships, there's fact tables, there's slowly changing dimensions. And so as FinOps practitioners, if you don't have a background in this arena, a data engineer is a critical skill set to add to your team early on. When Intuit started this process, it was comprised of about 3 to 4 data engineers plus Jason for the first 3 years. And they started adding some quality data analysts along the way. In addition to engineering solutions around pure FinOps data, like cloud costs or waste, there's going to be circumstances where special cost handling is necessary. And we as FinOps people need to try to get ahead of those circumstances, because an ounce of upfront data design prevention is worth a pound of re-engineering cure or headache. And even a little bit of bad data can spoil the whole process. So we need to hold our data providers to a really high standard. And so the key outcome here is the ability to relate or join the data sources together to provide a complete end-to-end picture for end users. So let's work through an example. Let's say we want to compare the forecast versus actuals for a budget group. And I'm just using budget group here as a generic term. Just think of it as any way to group your costs. So for instance, an AWS application. So you would need the forecast, which would be the budget amount, the month, and then the budget group. And then you would need your budget group members, which would be the budget group and then the assets underneath the budget group members. And you can just think of a cloud asset as any way you split up your costs. So it could be an AWS account or a tagged resource. And then you'd have your costs. So you'd have your assets, your month, and then the cost the assets generate. The forecast data would be pulled from the financial system. The cloud asset to budget group mapping would be pulled from the CMDB. And then the allocated costs would be pulled from your AWS billing data after all of the cleansing and business rules were applied. And then you join these 3 tables to provide the deltas of what you're looking for. So that's going to be the budget group cost, which is the sum of all of the cloud accounts versus the forecast entries for all of those budget groups. And then that would give you your answer. Resource level multi-tenancy is becoming more and more common in the modern cloud. So next we're going to go through 3 examples of how Intuit solves some tough material dollar problems with the same common data approach. We'll start with Kubernetes, which has infrastructure which is multi-tenant and technical in nature. We'll go over Amazon Connect, which is AWS's call center. And their issue was they had insufficient bill granularity. And then lastly, we'll cover Splunk, which is our third-party logging software. The first part of solving these problems is identifying the set of cloud accounts that we can bound or contain to generate the scope of treatment. And so this is where getting in early and providing guidance on system setup can really ease a lot of later manageability. Another key step is identifying the widget that the system deals with, and that's what will be used to determine the product vended or the meter that we measure the product. For Intuit, we isolate K8s, which are Kubernetes, into specific accounts. So we know all the costs of those accounts are related to K8s. The product vended is namespace, and the meter used to measure the allocation is CPU and RAM. Connect is naturally self-isolating in the bill, but we confine it to specific accounts anyways, just to make our lives easier. The product is the call queue, and the meter is the amount of time spent in the call queue. Splunk is a little tricky, but tagging works really well here because most of the costs relate to compute and storage, and those are highly taggable costs. And the product vended was index, and the meter used to measure was the index ingestion and search gigabytes. To know how to split apart multi-tenant costs and where they should go requires data beyond what's present in the bill. And this is what we call system telemetry. Gathering supplemental telemetry is the hardest part of this process because every system records things in their own unique way. And the data won't always be perfect, or the investment to make it perfect wouldn't be worth the return end product. So this is where judgment comes into play. You'll just have to get a feel for what's good enough and then move on. For Kubernetes, Intuit invested in a common Kubernetes platform, which we call Intuit Kubernetes Systems. From this platform, we gather cluster metadata and resource allocation data to containers on an hourly basis. Connect required an extraction from our internal customer care operational data lake. And Splunk required a special analysis of Splunk index and search activity. So then we bring it all together. We'll show how the same data strategy used in the forecast versus actuals example can be applied to these three scenarios. For Kubernetes, cluster metadata tells us everything we need to know about the active clusters. It tells us the namespace, the pods, the containers that are all running within the cluster. It also details the namespace owners, and it provides us with the container level resource allocation, which would be the meter that we use, so the CPU cores and gigabytes of RAM, all on an hour-by-hour basis. And from this, we can calculate which percentage of the cluster's resources went to each namespace. And then we use that percentage to break apart the in-scope costs and allocate them to the individual namespaces. So now we have individual namespace costs. We just transformed the original AWS CUR to Kubernetes-aware namespace level costs. For Connect, we obtained the call queue details from the customer care data lake, joined that with the data from the call center cloud accounts, and then we derived at the call queue costs by the correct party using the call center. And then it was a very similar approach with Splunk, but instead of cost of a namespace or cost of a call queue, it was cost of an index, and that was allocated to the correct party. Here are some other FinOps problems and the key data sources we use to address them. Whenever you set out to solve a new FinOps problem, a key early step is identifying the data ingredients necessary to provide for an accurate and lasting durable solution. And so some examples, we went through the first two, but if you wanted to solve for prepay management, you'd look at the detailed cloud bill and history, the price lists, and then the business forecasts. And then similar process for EDP negotiation or auditing a cloud invoice. And so the more data you have, the easier it is to onboard even more data, and then the richer insights you can provide to your customers. That's it, I'm early. But I can take any questions if anybody has any.
No way. I don't believe any of you. There we go, Allie. There we go.
First off, you did an amazing job for pulling this together. Very, very, very well spoken on it. And it kind of led me to think about this because you're kind of more of the connecting the dots to the business side as well of it too. How well do you kind of understand the transparency of the transformations that happen behind the scenes and kind of the cleansing that happens with the data?
Not very well. I mean, I've looked at the code for sure, but it just looks like a different language to me. I can do very basic SQL queries, right? And I understand essentially what's happening, but like, I don't understand what's happening with cleansing. Yeah. We have a whole set of data engineers and analysts that do that.
Do the teams who are accessing the data, do they ever ask questions about kind of what the fields are that are changed or are manipulated?
Not for general prepaid management or EDP discounts. They want to know that they are embedded in the costs that they're seeing. Mm-hmm. But it's more, the questions that I get from the customers are more around allocation of their costs and what is the makeup of those costs.
Okay.
Which we typically can provide to them. So like we can tell them the exact instance and what's running in that instance.
Awesome. Thank you.
So my question is that you guys created an internal tool, right? So the data that you are getting from all these cloud providers, that starts growing very quickly, right? So how long do you archive that data, like historically, and is that a problem? Like, how did you guys solve that?
Yeah. That's also a question I'm not sure. I want to say we archive everything, but it's where we keep the history, right? Like we move it into an archive. And then in our most recent tables, I think we keep 3 years. Yeah. And so that's what all the dashboards are fed from.
So I wanted to ask, how big is the team for managing this?
Mm-hmm. Well, we're hiring. We have some open recs. I think right now we have 9 people, and we're trying to hire 2 more.
And what was the motivation behind build versus buy some of the tools that are available in the market?
It was, well, we do have some, like we use ClickSense right now for some of our tools, but we wanted just more capabilities that we couldn't find on the market. So we wanted specific alerting, and we wanted also our users to be able to customize their dashboard. So we created a dashboard called Cloud 360, and a user can go in and create a scope. And so a scope is anything from a BU level to a tagged resource. And so then when they log into this dashboard, all they see is just the area of the scope they created. And then they can set up alerts from there and get weekly updates on that specific area. And there really wasn't a tool that could do that. Mm-hmm.
For your time allocation, you said you used your data lake. Was that data already there, or did you have to custom put metrics out there to correspond to the allocation?
Yeah, we had to put custom metrics on there.
How did you decide which ones to do?
Don't know.
Okay.
You can maybe ask Jason on Slack.
In the first slide, you mentioned that there are 100+ sources from which you get the data. So apart from the default sources of CUR and BigQuery exports, what kind of data do we get in? Is it like organization hierarchy or business requirements?
Yeah. So it's a lot of that gathering that supplemental telemetry that I was discussing. So if we have to connect to a different data lake or bring in sources like all of our Kubernetes information is actually through a few different sources. So it's just, I think, this telemetry that we need to connect all the pieces together.
And for platforms like Splunk that you use, is it being built through marketplace of your cloud provider, or is it independently built?
It's just within Intuit right now. Yeah.
Other questions? Steph, do you have one?
Hey,
Hi.
for your team, kind of narrowing it down, what do you think the next big challenge that you guys got to work on for this or anything else?
Yeah, good question. We are trying to shift left. We already have really robust tools to show waste and which teams are driving the waste. But we want to get ahead of being reactionary and bring it more into the code and identifying before they even deploy an instance what they used inefficiently. So that's something that's big. And then just getting the engineers to take action. I really related with that first complaint because that's part of my job and it's hard without executive sponsorship, which is what we're struggling with as well.
I have one question here. Is what you're doing, gathering all those data sources, is so much more complicated than a majority of what we see FinOps teams doing for their showback chargeback method. And even when it's really simple, you get a lot of pushback from application teams. If you're doing a much more complicated sort of chargeback, showback attribution, what is I'm not familiar with the Intuit culture enough to know what is the response, what is the reception? Are you getting that pushback frequently, and how do you deal with it?
Well, we call ourselves a platform team, so I would say in everything is one Intuit something, right? One Intuit data lake, one Intuit customer care. And so with that culture mindset, everyone is really open and receptive to connect to their apps and APIs. And we really haven't had a lot of issues. And if you explained the end result of what we're trying to solve and the value that you can provide, they're much easier to go along with letting us connect.
That's amazing. I mean, the amount of pushback you have for just one cloud. There we go.
So this is the last speaker was right. This is incredibly sophisticated in terms of how you not just show waste, but codify why that specifically is wasteful. And I have that carries a lot of power. My question is, once you determine something based on the metrics, once you determine something is more costly than it should be, or the cost has to go down in order to meet those metrics, who then takes on that task of determining what to do next?
Yeah, that's a good question. So we really hold the engineers accountable for their own waste, or their dev managers accountable. So what we do is we review the waste. We have waste percentages by BU. And so we review those monthly with the CTO, and we have a threshold that every BU should be under, a percentage threshold. And if they're over, then that flags the CTO's concern. And then from there, teams typically reach out to me, and we set up monthly meetings to get them on track to get their waste down.
So at your scale, is waste coming more from dev usage or orphan resources, or from discount mismanagement or floating or something?
No, I wouldn't say it's discount mismanagement. We don't have a lot of RI waste. It's mainly from dev. Yeah, inefficient resources like S3 versioning. Teams not enabling intelligent tiering, or IKS container utilization, which that's Kubernetes container utilization.
And is that a linear growth as you scale more and more and more?
It is. That's why we're trying to shift left, so we're catching these problems and we don't have to be so reactionary.
Thank you.
Mm-hmm.
Sorry, I got lazy and I didn't run it back to you. There we
On the waste piece, did you ever encounter early on that was maybe viewed as like shaming the dev team and it inhibited some of the adoption of the FinOps practice?
I haven't seen that. So I've only been in our FinOps org for about a year, so I wasn't there from the beginning. We call them savings opportunities versus waste. So it's a little more positive, right? But I haven't seen where engineers feel shamed by any means.
Changing the name does help.
Yeah,
Yeah.
right.
I guess we can say that you have a culture of positive reinforcement then, is that right?
Correct, yeah.
So do you guys, does your team then provide facilities, mechanisms, tools, et cetera, to help the people who you've identified waste with then to figure out what to do to solve that problem?
Yes. So the Cloud 360 application that we're building internally has the savings opportunity details for a specific scope that an engineer creates. And what they can do is click on the details and from there see the specific waste, and they can click on the specific waste and it will actually tell them what exactly they need to do. And from there, we call it guided remediation. They can then click the link for guided remediation and it will bring them to the AWS console where they can make updates.
Yeah, so you guys put a lot of effort into building out the pipelines, getting into a great data lake, just make sure the data is all there. How do you guys manage who gets access to that data? I saw on one of the slides, there's like APIs and views that you can build out for other teams. As far as the views and APIs that you guys do build, are they more of a pull and request from your end users and the dev teams, or do you guys facilitate that yourself?
It's always a pull and request. So there's certain, like our AI group likes to build their own dashboards for cloud costs. So we give them API access and then they pull and request. But it just depends on the use case. And we just try to understand really what they're using the data for. And Jason really makes the end call determination whether, how we're going to provide the data to them.
All right, Gina, you nailed it. So fantastic job.
JR here from the FinOps Foundation. Thank you for watching. Please go to FinOps.org if you want to get plugged into this amazing community. And of course, hit subscribe right here on YouTube to get all the future content. Hope to see you soon.